welcome back.
Hi.
All right, so we're continuing in our study of quadratic functions. Yesterday we looked at what they were, that they were kind of round, they looked like U's. Then yesterday we looked at substituting into the equation and evaluating it out and using various values of x to generate values of y that then we could put onto graph paper and graph. Well, today we're going to be looking at the characteristics of the quadratic function and then graphing this thing directly from the equation and using as few points as possible. Because I know yesterday's homework you had to use like a bunch of points and you're still working on it and it's annoying because there's a lot of work to do. I'm going to show you how to kind of turn that down a little bit, make it faster for you. Here are the characteristics of quadratic equations. Some of these are familiar, some of these maybe aren't. I don't know, we'll see which ones are familiar. These are the functions we've already studied. We've studied linear equations and we've studied absolute value. Let's go through each one of these and see which ones apply to the things that we've already looked at. All right, x-intercept. Did we deal with x-intercept with linear functions? Yes. All right. Did we deal with x-intercept with absolute value?
Yes.
I love that tone too. That was like, yes, we did. What about y-intercept?
Yes.
For which one?
Both.
Both. Okay. What about domain and range? Absolute value for sure.
Both.
For both of them. Okay, I'm feeling lazy for writing. What about you? Yeah, you can put arrows. I like putting these little quotation marks. Go ahead and close it.
Spooky season.
Spoopy, my door opened.
No way.
I have a feeling we didn't close it right, and so when they opened the
So
door to
scared
the
there.
outside,
They want us to get
it sucked, yeah. Sure, we're gonna say that, not that it was a ghost. Because that would be spooky.
Welcome to class. Get ready to.
Yes, welcome, come in. Don't forget to grab your stuff, and there's seats there in the back and here in the front. We're welcoming Casper. Thank you for joining us, Casper.
Yeah, sure.
Axes of symmetry. When did we deal with axes of symmetry? Linears or absolute values?
Absolutely.
Yeah, absolute values. What was that axis of symmetry in absolute value?
The X.
Oh, because the equation was x equals?
Yes.
I like it. Yes, you're not wrong. What about maximum minimum? Which one? Absolute value for both?
Yes.
Good. Could we talk about maximum and minimum with a straight line?
No.
Why not?
Because it's a straight line.
Because there's no curve, it's a straight line, it's going on for forever, and it doesn't bend because it's a straight line. Great. Let's graph the thing and let's identify these characteristics. How do I graph this thing? By calculator. You're not wrong. You could totally. Let's do this by hand. Here's how I want you to think about how we graph this. Pretend for a second this were an absolute value. It's not, but just pretends for the funsies. If it were absolute value, what would that tell you?
That is. Isn't it like the left 3?
Yes, we're shifting it to the left 3. And if this were an absolute value, what would this tell me?
Go down
4.
Good. Now, if we think about our parent function from day 1, and I'm going to flip back real quick to my notes from day 1. Just pull it out of my notebook here. This was what the parent function looked like. I'm going to grab this bottom point. And I'm going to move that point from 0, 0. I'm going to move it 3 to the left and 4 down. 1, 2, 3. 1, 2, 3, 4. And in my pen, I'm going to put a big dot right there with my pen to say, I'm moving it. Huh?
That's your minimum value.
Ooh, I love that. Yes, it becomes my minimum value. Because if I were moving this function, if I were grabbing that dot and moving it down to here, it still opens up. That point is our minimum value. It's the lowest that we have. Beautiful. So I'm going to go ahead and circle minimum. And I'm going to put the coordinates of that point. because we already identified where it was. These are so good. All right. You've already seen the parent function, so I'm going to use the parent function. I'm just going to have my notes sitting out here next to me, and I'm going to use that to really roughly, ugly sketch what I think this parabola should look like. Do that with your pencil. Let it be ugly. Let it be weird. All right. Okay. You should just barely be able to see it. Do you want a pencil? Pencil. Does anyone else need a pencil? I've got an extra one. I'll throw it at you. Gently, gently, like a pencil. As Val moves out of the way. Okay, no one needs a pencil, so I'm not throwing things. All right. From here, how many x-intercepts does it look like we have?
2.
Okay, looks like we're going to have 2. So I'm going to write that we have 2 of these, and we'll see if we can't find their coordinates a little later. How many y-intercepts does it look like we have?
1.
And again, I'll try to find the location in a bit. What does the domain look like it is? What was it again? You're absolutely right. Looks like it's all real numbers. Because it's continuing to open and getting wider and wider and wider. Yes? What about the range?
Isn't it y is greater than
It is. Good job. Axis of symmetry.
And that'd be x equals 3.
It would be this vertical line x equals 3.
Miss, we have a question.
Negative 3. Answer.
So the axis of symmetry is the middle measurement?
Yes, ma'am. It's that line that you put right in the middle, that if I were to fold my paper, it would end up on itself.
Basically your minimum or maximum.
It's the straight line that goes to your minimum or your maximum. Yes. Thinking back to absolute value, what did we call this point that axis of symmetry went through?
Vertex.
Right there.
The vertex. Guess what we're going to call it with quadratics?
Vertex.
Nothing changes. All right. Let's try to find the x or the y-intercept. All right. The y-intercept happens when the graph crosses the y-axis. What is the value of x at the y-axis? Let's look at my graph. Here's my y-axis. What's the value of x along this line? It's 0. I'm going to use my table of values to help me generate what the value of the function is when x equals 0. All right, so this should feel really familiar, especially if you're already working in day 2 assignment. You've done this like already 30 times and you're like masters at this by now. All right, so let's play this game. 0 plus 3 is?
3.
3 squared is?
9.
9 minus 4 is?
5.
My y-intercept happens at the point 0, 5. Ask me a question. No questions? Over in here?
Is that only for the y-intercept?
Only for the y-intercept.
So whenever you look for the y-intercept, you can do that.
We're going to do this. You're going to set x equal to 0 and then figure out what y is.
You basically just replace the ones on this side for the x.
Yes, ma'am, I'm just replacing x with 0. And whatever value falls out of my equation, that is the location of the y-intercept. Which means now I can take this coordinate and I can plot it here. 1, 2, 3, 4, 5. That's where my graph should go. I was way off with my pencil. Look at that. That's okay. Do not erase. Do not erase your old graph. Plot your new point. And either with your darker pencil or with your pen, make your new graph. I missed. Right? He's trying to take the hall pass, Casper. I missed.
Five.
I'm going to try this again. There we go. So maybe do it with pencil, and once you feel more comfortable with it, then trace it in pen. Okay, I'm gonna try to make this like super dark. All right, that feels good. I don't know what's happening with the other side yet, but I've got this side feeling more comfortable. Based off of my new adjusted graph, where does it look like the x-intercept could be? It looks like it's right here at x is -1. So what we're going to do is again come to our table of values. We're going to put in a -1 for x, and we're going to see if what we get out is a 0. Because if it is a 0 right here, then this is indeed a y-intercept. We have our x and our y-intercepts. Okay, let's check it. -1 plus 3 is, try again.
No.
2. 2 squared is?
4.
4 minus 4 is?
0.
One of our x-intercepts is at -1, 0. Ask a question.
Do we plot it?
Yes, ma'am. If you don't have a question, plot it. On my plot, it's like perfect.
Oh, I missed it.
Okay, and now you can adjust it. So on the homework assignment for here, I should see in pencil, very light, your first attempt at drawing the graph off of just the vertex. It's not going to be accurate. It's probably going to be too fat or too wide, and that's okay. Just put it on there. You're correct with whatever you draw. Then I should see you kind of starting to guess how many intercepts, right? X and Y. The y-intercept is going to be the easiest to calculate because it's always x is 0. Throw x is 0 in there, figure out where the y is, and then use that to make a better graph. And then from there, if you have what x-intercepts, you can take a closer guess as to what it might be, put that in a table value, and generate the y to confirm. You're looking for it to be 0. Yes! We have to draw the other side of the graph, though. I don't want to deal with any more points. Do you?
No.
I don't either. So here's how you do it faster without using table values anymore.
But in half.
Yes, we're going to basically fold the thing in half, except I'm not actually going to fold the thing. Look, check this out. Okay, so zoomed in really tight.
Copy and paste.
How far away is this point from the axis of symmetry?
2.
2. So from the axis of symmetry, I'm going to go 2. 1, 2, that point should be here.
And then you go.
I'm going to do the same to this point because I know where it is. 1, 2, 3. 1, 2, 3. And now I've got enough points that I can...
Yay.
Whoops. Wait, hang on. Oh. Look, it's hard to draw under a camera. It like bonks my pen and sounds like an excuse. I'm sorry. Yeah. But that's the general idea. Good. I have 2 other examples if you guys want to see them, whole group. We got it? Got it? Feeling good? Over here, this side. And then right in here, this corner. Happy? Goodness? Okay, we're done. Thank you very much.
Thank you.